Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can solve polynomials part 2. Now, when we're talking about solving polynomials part 2, what this means is we're actually talking about how can we solve polynomials when they either have complex solutions or when they have radical solutions. So those solutions that are non-rational, how can we find those? So there's some special properties that we learn about complex and radical solutions when it comes to solving polynomials. And they're pretty related to each other, which is kind of awesome. So if there is a polynomial with an imaginary or a complex number solution, what that means is it actually comes in a pair. So we're gonna have both the positive and negative version of that pair. So we're only ever gonna see complex conjugates or imaginary numbers. So those imaginary solutions will always come in pairs. So you're never only going to have one imaginary solution. You'll have a pair of them. Same thing with irrational ones. Anytime we have a radical here, what's going to happen is any of those irrational solutions will also come in pairs. And so that's super important to keep in mind. So as we're solving something out, we're going to end up getting the square root of 2, but we also might end up getting the negative square root of 2. So we want to take into account both. Now remember, the fundamental theorem of algebra tells us that we are going to have the same number of solutions as the highest degree. Now in our previous video where we were reviewing how to solve polynomials, remember we saw all those times where we got the same number of solutions. Now in this case, we need to continue solving them out, and we're going to have some that are rational solutions and some that might be irrational, some that might be complex, things like that. But we're still going to follow the same process that we did before to find these solutions. So we're going to try our two different methods. Typically when we have imaginary solutions or irrational solutions, we're going to actually find those through factoring and our factoring method, and less so through our rational root method, because remember, the rational root theorem only will give us the rational roots of a polynomial. So a lot of this that we're doing today is going to be practicing with that factoring. So let's go ahead and take a look at some of these. So let's solve this polynomial here and find all of its roots. Now I'm going to very first start here by trying to factor out a greatest common factor. Now I don't see a greatest common factor. So what I'm going to do is I'm going to then try factoring it. So because there's 4 pieces, I'm going to factor by grouping. And then factor out an x cubed, and we're going to get an x plus 1 here, and then we'll factor out an 8 here, and I'll get an x plus 1. Ooh, beautiful. This is going to factor great for us. So then we factor out that x plus 1, and we get x cubed plus 8 equals 0. Okay, fantastic. Now this is awesome. This right here, this first piece is factored completely, but this next one isn't. But we do actually know how to factor that. Remember that that's a sum of perfect cubes. And so we can factor this out into x plus 1 times x plus 2 times x squared minus 2x plus 4 equals 0. Okay, factor completely. This one is not. But as I try to factor this using my x method, I don't know about you, but I cannot come up with any numbers that multiply to 4 and add to -2. So guess what we're going to have to do? Whenever we run into a quadratic trinomial, so a trinomial, so an x squared trinomial that can't factor, what are we going to do? Well, that's one of the favorite things of every mathematician is the quadratic formula. So what is the quadratic formula? Well, as a reminder, what it is it gives us the solutions when x equals 0. And that quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So let's go ahead and use that quadratic formula here. So I'm going to write that out over here just so we have it as a reference. So negative b plus or minus the square root b squared minus 4ac divided by 2a. Now in the past, you might have stopped when that, what's called the discriminant, or the thing underneath the square root, was negative. However, because we're trying to find both the real and complex solutions, if that number is negative, we're going to continue moving on with it, knowing that that's going to be an imaginary number. So let's go ahead and take a look at what this will factor into. So in this case, a equals 1, b equals -2, and c equals 4. So let's go ahead and plug that into our quadratic formula here. Now note, as we plug it into the quadratic formula, see how it's x equals? So what this does is, unlike these other two pieces that I'm going to set equal to 0 and solve for x, this one will just tell me those x values immediately. So what we're going to do is we're going to do negative b, or the opposite of b, plus or minus the square root of our b value squared minus 4 times a times c divided by 2 times a. And as we simplify this, we get 2 plus or minus the square root of 4 minus 16 divided by 2. And this is going to be 2 plus or minus the square root of negative 12 over 2. Okay, so now we're running into this problem where we have a negative radical inside. What do we do when we have a negative radical? Well, remember that negative 12, if we were to break it down and simplify, it breaks into negative 1 and 12 breaks into 2 and 6, and 2 and 3. So I know I can factor out a 2. Now, negative 1 actually breaks down. By definition, I squared, or I times the imaginary number times an imaginary number, is negative 1. That's the definition of an imaginary number, or the square root of negative 1. Therefore, we can actually break down this negative 1 into an I. So as we simplify this, we end up getting 2 plus or minus 2I root 3 over 2. Now with this 2, we can actually divide and simplify these, and we end up getting 1 plus or minus I root 3. Now remember at the beginning of this video when we talked about how those imaginary solutions and those irrational solutions are going to come in pairs? That's what this plus or minus is referring to, is our pair. So as we're finding our solutions here, we've got that x plus 1 equals 0, so x equals negative 1. X plus 2 equals 0, so x equals negative 2. And then lastly, we have this x equals 1 plus or minus I root 3. Well, what this really is saying is that we have two solutions. X equals 1 plus the imaginary number times the root of 3, and x equals 1 minus the imaginary number times the root of 3. So this actually includes two solutions. So I've got two solutions here and two solutions here. Now, I need to check with myself. Are these all the solutions? Well, yes, because look at our first term here, x to the 4th. Now that 4 tells us I need to have 4 solutions according to the fundamental theorem of algebra, both real and complex. And how many did I get? 1, 2, 3, 4. So boom, that's how we're going to do it. So what we're going to do here is whenever we're trying to find these solutions, the reason why we always want to try to factor is because we can really only find those complex or those radical solutions when we factor. We can't find them using the rational root theorem. So we're always going to try to factor first. And if one piece factors, then we're going to continue on. Now, anytime that I see an x squared minus 2x plus 4, or any x squared trinomial that can't factor, we're going to use the quadratic formula. Now let's take a look at one other problem here. And that's going to be this one. So I'm actually going to factor out this, or solve this one. And very first, remember, we want to find our greatest common factor. Is there one? Nope. So now let's try that factoring route. So I'm going to factor this using the x method. Now remember, this is just a trinomial, but with an x to the 4th and an x squared. So we can factor this, and we're going to end up getting an x squared times something and an x squared times something. Unlike when we have a trinomial with an x squared and we just factor it out. So I need two numbers that multiply to negative 144 and add to 7. So as I'm running through that list of numbers, what are numbers that multiply to 144? Well, I know that 144 can be broken down into obviously 1 and 144 and 2 and 72, but I don't want to keep trying all those numbers. These ones are too big apart, but I do know that 12 and 12, but 12 and 12 is not going to give me 7. So let's try something below that. 11 is not a factor of 144, 10 is not a factor, but 9 is, and it's 9 times 16. Ooh, interesting. If I need a negative here, so one of them needs to be negative. If I have 16 and a negative 9, 16 minus 9 is going to be 7. So that works. So we've got a negative 9 and a 16. So a negative 9 and a positive 16. And this is equal to 0, right? So now we need to solve this. Well, I can actually factor this one even more. And what I'm going to do is this is actually a difference of squares. So this is x times x. This is 3 times 3. So this one breaks down into x plus 3 times x minus 3. And this is x squared plus, not 14. This should be a 16. Equals 0. Okay, now this one is not a difference of squares, so we cannot break it down that same way. So whenever we have an x squared in a binomial, what we're going to do is we're actually going to set it equal to 0 and solve for x, or solve for the variable. So what that means in this case is I'm just going to set this part equal to 0 just like I usually do when I'm solving, but then keep going till I get x by itself. So I have x plus 3 equals 0 for one solution, so x equals -3. X minus 3 equals 0 for one solution, so x equals 3. And then x squared plus 16 equals 0. Well, I'm going to solve this by subtracting 16 from both sides and get x squared equals -16. Well, to undo this square, I'm actually going to square root it, and I get x equals the square root of -16. Well, first, let's break down that -16 to see what it square roots into. Now, remember, anytime we have an irrational number or a radical, that means that in our solutions here, we're going to end up getting the plus or positive and negative version of this number. So keep that in mind. So -16 breaks into 1 and 16. 16 breaks into 4 and 4. 2 and 2, 2 and 2. Now we can either circle two groups of 2 and pull it out, or we can notice that we have a set of 4s here and pull those out. Now remember that our -1 breaks into I and I, so we can also pull an I out. So this ends up getting us that x equals the positive or negative 4 times I. So what are those two solutions that this will give us? Well, x will be 4i and x will be -4i. And so then we have 4 solutions here. X is -3, x is +3, x is -4i, and x is +4i. Now looking back at our original problem, is this all the complex solutions, or is this all the roots that we can have? Well, according to the fundamental theorem of algebra, we can have 4 here. And as we look down at this problem, we end up with 4. So again, what we're going to do here to solve is we always want to start by factoring. If we can factor one piece, then we're going to keep going. And we want to look for that sum of cubes, that difference of cubes, that difference of squares. If none of those work, then we either want to try the quadratic formula, or we want to set that piece equal to 0 and solve for x. Okay, and once we do this, that is how we can solve polynomial equations when they have radical and complex solutions, not just rational ones. If you have any questions, feel free to reach out, but that is how you can solve polynomials with complex or radical solutions.